In this endless space, the entire universe is vast, teeming with countless galaxies and stars, and the planets, life, people, everything in between is all mostly made of matter, and still evolving. But according to astronomers, the universe was not looked always this way. Everything around us that exists all begins in a Big Bang. To understand how the universe and everything come to be, we must travel back to the beginning of time. Wind the clock backwards, long before the Earth and the Sun will condense in the interstellar gas and dust. Long before stars and galaxies were created, and everything that we know in the cosmos shrinks into nothing. Almost 14 billion years ago, there was absolutely nothing. Then, it exploded. In a flash, the universe began as an unimaginably small dense point smaller than an atom expanded, and the pure energy is released. Gradually, the hot baby universe cools. Conditions for atoms to form, mostly hydrogen and helium. Until 100 million years later, clouds of hydrogen and helium is collapsed inwards by the pull of gravity, that it becomes hot and dense enough to ignite the very first generations of stars. Eventually, vast clusters of countless stars are taking shape, assembling into a bundle of them, eventually form galaxies. Each galaxy contains countless stars. Some are spiral, elliptical, and irregular. Others collide and fuse, merging into one. Perhaps 10 billion years pass. Then we encounter the spiral galaxy, the Milky Way. In it, stars are formed, and some of them die in epic explosions. Our sun does not yet exist. Before 9 billion years later, some of these stars are more massive than the sun. But deep inside the interiors, it's producing something astonishing. Deep inside the giant stars, hydrogen is converted into heavier elements like carbon, nitrogen, oxygen, on up to iron. When more iron is fused too much, the core becomes very critical, that it causes the star become unstable and explode violently. Supernova explosions expel out the ingredients of life onto this giant molecular cloud. Until 4.6 billion years ago, a huge cloud of gas and dust is disturbed by the shockwave of an exploding star. causing it to collapse by the inward pull of gravity. Then it begins to spin, forming a giant rotating disk of matter. In the center, clumps of gas clouds becomes hot and dense enough to ignite a new star, and the sun is born. Around the rotating disk of material left over when the sun was ignited, dust grains gradually form into rocks. Then rocks collide and fuse, forming boulders. Then boulders attract more debris, eventually form into planets. One of those planets is Earth. It's a ball of molten inferno and lava. It's constantly bombarded by comets and meteors. And the heat sank heavy material within the Earth's interior, forming a metallic core. Its surface stayed hot, that is gradually cooling. And there's no place for water and life to exist. But the question is, how did they get here? Somehow around 4.5 billion years ago, the young Earth is on a collision course with a small protoplanet. The collision blasted debris out into space, then into orbit around the Earth, forming a ring of swirling shattered material that circles around the Earth. Over time, the debris coalesce into the ball that will form the moon. It was closer back then, before it moved just 250,000 miles. Then, about 4 billion years ago, the surface of the young Earth is a very hostile world, with carbon dioxide, lava, and erupting volcanoes, spewing toxic gases, and the atmosphere begins to form. Then, the Earth was bombarded by swarms of asteroids and comets that some of them delivered mostly water. Gradually, over thousands and millions of years, Earth cooled, and the water vapor condensed into rain. Covering the surface with pools and lakes, and eventually the oceans. Until 3 billion years ago, the Earth is covered in oceans, with rich seas in the primordial soup, containing chemicals of organic molecules and amino acids. Conditions for life to begin. Within these seas, these organisms were microscopic single-celled bacteria, somehow reproduce. and some of them take in the energy of sunlight, converting carbon dioxide into oxygen in the process of photosynthesis, allowing green bacteria to multiply and form colonies called stromatolites. And the vast amounts of oxygen is released in the atmosphere and is shielded against the sun's deadly radiation. But how life evolved into advanced creatures that we know today. For millions of years, the increasing oxygen allowed bacteria to evolve into cells with a nucleus. Some of these cells become so complex for multicellular life to begin. About 530 million years ago, multicellular colonies formed corals in the ocean floor, and the primitive sea creatures evolved, including trilobites. The first evolved predators is the Anomalocaris, and the very first vertebrates are the primitive fishes. Until millions of years pass, the first vertebrate ancestors are still evolving. Until in the barren lands of Earth, algae that make it to the land form the very first plants that has to the key to the rise to form trees and forests that cover every continent. Perhaps 300 million years pass. The giant amphibians appeared that step out of the water onto land. In the late 300 million years ago, much of the land on Earth consists with forests and swamps made of arthropods and the flying giant insects. Some millions of years pass until reptiles and dinosaurs appeared. Before the first mammals evolved. In space, the continents on Earth are still evolving, controlled by the churning tectonic forces. And the giant supercontinent, Pangaea, breaks apart to form the 7 continents that we know today. And the giant reptiles, the dinosaurs, dominated the Earth for hundreds of millions of years, including brachiosaurs and triceratops, and some of them fly in the skies. Including this predator is the Tyrannosaurus. And suddenly, in 65 million years ago, a threat that brought to the end of the dinosaurs. Because thousands of miles away in space, a giant asteroid, about 6 miles across, is traveling 40,000 miles per hour, is on a collision course with Earth. And when it burns in the atmosphere, it strikes violently. The colossal impact is equivalent to 100 million megatons of TNT, blasting billions of tons of vaporized rock and debris in the atmosphere. And the heat scorches everything in its path within a 1,000-mile radius, igniting massive wildfires. And dust and soot cloud from the impact blocks out the sun, resulting global darkness that lasted for months, and the food chain collapsed, and 3/4 of life on Earth, including the dinosaurs, went extinct. Except for smaller animals, the mammals survived as well underground, until Earth slowly recovers. After Earth recovered from extinction, little mammals flourish and have ability to dominate the Earth before they evolve into primates millions of years later. And the primate ancestors have the ability to walk before they become into humans, until their brains develop and they become more smarter, until they migrate. And this is the beginning of the new age of humanity. And after the cold ice age period, around thousands of years, the migrating ancestors were explorers and hunters. They used advanced tools to conquer the land. That has to the key to the rise of the age of technology and civilizations that become so complex over thousands and hundreds of generations to the modern times. And the age of discovery will look back in the past. And the age of space exploration send astronauts into space for the next generation and the scientific research, and to understand the universe, and yet the future. In the present time, the universe is around 93 billion light years across, and its age is about 13.7 billion years old. It contains mostly galaxies, stars, worlds. Even our insignificant planet is about 4.5 billion years old in this endless space. What about if we travel into a distant future? Is our universe continues to expand? Is everything will possibly end? Before it begins, it starts with our friendly star that provides life. In the next 5 billion years, the sun is running out of its hydrogen that powers the star. Its core will collapse, that it starts burning helium, causing it to rapidly expand. Back on Earth, life will be impossible. The oceans boil, and the surface will melt at 1,000 degrees. And the sun becomes a huge red giant. At that time, it will expand so much that it will devour Mercury. and Venus. And probably the bloated star engulfs the Earth. When its supporting fuel is gone, the dying sun becomes so unstable that it expels its outer layers, devoid into space. Leaving its core remains is a white dwarf that it will eventually cool into darkness. But let's imagine if we travel some trillions of years from now, the universe continues to expand faster. Galaxies will fly apart, and stars become isolated and burn out its fuel. And the universe becomes cold, dark, and empty. And eventually, matter as we know it will cease to exist. Until finally, the universe is dead. Fortunately, the universe is currently stable. After a journey through space and time, we're finally back home. Back on Earth, all living organisms on this special planet are made of elements are inside our bodies. The calcium for our bones, the oxygen in the air we breathe, and the iron for our blood, and the carbon sustain life, and the raw materials that make up cities, buildings, and machines. All of these sustaining elements originated by long dead stars, and everything else in the cosmos always depends on it. It's revealed by science than they could ever imagine.